Hello and welcome to video number 34. We're going to be talking about simple harmonic motion and the diagrams that can be used to simplify it. Alright, so simple harmonic motion, two most important things are the period, which is represented by T, and that would be in seconds. And then we also have frequency. Which is given in or hertz. All right. So for simple harmonic motion, there's usually two things we're talking about, or at least the two most common. There is a spring system, and then it's an oscillating spring system. For example, one that's hanging or to its side, or usually a pendulum that's oscillating from side to side. So those are the two ones that usually a lot of problems focus on. So let's see how we can make a diagram for these and label it. So let's start off with the spring, oscillating spring on its side. So we're going to assume this is a frictionless surface just to make it a little bit easier. All right, so let's say that this is outstretched, so let's call this the reference point right here, and then call this A and this negative A. So these are the 2 points that it will go to, oscillate from one to another, and the period is how long it takes to get from A to negative A back to A. So that'd be one period. And then let's take a look also at all the velocities and everything. So it has a velocity of 0 out here actually. So out here it has no velocity. Then in the middle it reaches its max velocity, and then out in negative A it once again reaches a velocity of 0. So this would just continue oscillating. And then also, we can find the displacement at any time by using the equation with that if we wanted to find how far away it is from something at that point. Now let's take a look at problem number 34. So here we have an oscillating spring system hanging from the ceiling with the reference point at x equals 0 here. This is dragged down to here, so it's 15 centimeters away. It then it also has a period of 2 seconds. So it takes 2 seconds to get from its original position back to its original position. All right, so question number 34 asks, what is the total distance traveled by the object during the first 20 seconds, 2.0 seconds of its motion? So the first 2 seconds. That's how much motion, how far does it go in its first period. So we know a period is, it goes from here up to here, then back down. So on its way up, it goes through the first 15 centimeters, and it goes up again another 15 centimeters, so we know 30 centimeters so far. and then it goes back down 15 centimeters, so another 15 centimeters, and then all the way back down to its original position. So that means there's another 30 centimeters that it travels. And since it traveled from its initial position up to its maximum position, and then back down, we know that that's one period, which is 2 seconds, which we tried to find out. So, in total, it traveled 60 centimeters, which is option C.